My name is Sasha. I am a contributor to the Lido DAO. I'm a product manager, and me and my team recently launched the product. And for me personally, it was the very first product I built from ground up. And that was quite a journey, I have to say. And today I want to just walk you through the journey together with me, not the entire journey, but just a small piece from like an explorational phase to understanding the problem and to even considering the design space and trying to choose the right design solution. All right. So yes, before we got to the designing the product, we need to understand what Lido is and what it does. Okay, and for this, we need to dig a little bit into Ethereum. We all know that Ethereum needs validators to perform their duties so that our transactions can pass. All right, so yes, the beauty of Ethereum is that anyone can create a validator. For this, you need a hardware, a stable internet connection, some pieces of software, and no more no less 32 ETH. All right, and this 32 ETH serve as a guarantee that you will perform your duties, not you, but your validator will perform your duties on the network correctly, according to the rules. All right, this requirement of 32 ETH creates one of the most challenging issues on the Ethereum network that, yes, there are a lot of people who has desire, who are willing to run a validator, and there are a lot of people who have this capital, but the intersection between these two is quite small. All right, let's take a look how Lido in particular and in general liquid staking protocols solve this issue. All right, we have this ETH holders, people who are ready to provide their capital. They put their ETH into the liquid staking protocol that allocates this ETH to validators. Validators perform their duties on the Ethereum network. They get rewards that are split between validators, liquid staking protocols, and ETH holders. And it seems like the challenge is solved, but not really. So the deeper we will dig, the more challenges we'll find. Now let's take a look at the validators side of things. So as we already discussed, the validator is a piece of a software that is set up on some kind of hardware. And node operator is an entity or individual, meaning that it is like a person or a group of people. All right, so node operators, who they can be or who are they? So I would say that generally there is a division and we can say that there are solo stakers and professional node operators. All right, solo stakers is just individuals like you or me or anyone else in this room who voluntarily want to run a validator at their home, maybe not necessarily at their home, but they usually combine this duty of maintaining the validator with their regular job in a real world. So, and it means that they have less time for maintenance and it can affect their performance. But the best thing about solo stakers is that they are individual, they're independent from each other in terms of their like jurisdiction, in terms of their geolocation, in terms of their even like views and interests. So that is exactly what Ethereum wants to have to stay decentralized and diverse. And the other side, professional node operators. These are organizations who do this as their basically business. So that's the way the Ethereum validation for them is the way to earn money. All right, they are quite experienced. They can ensure the stable maintenance of their validators, but they are usually called a single point of failure. And what I mean by that is this. So if you take a look at this example, we have 30 validators here. All of them belong to 30 different node operators. And we have 30 validators here, and all of them belong to only one professional node operator. And if we imagine that something happened in a particular region, a particular city, where one professional node operator and one solo operator live, what will happen? We'll have this kind of picture with the outage. So, of course, this is an extreme example, and everything is not that obvious, and professional node operators do care about like diversification of their servers, of their clients, but it's just a good example to show you what I mean by this single point of failure. All right. How do node operators join? Again, two polar opposite approaches. The first one is permissioned, meaning that a node operator needs permission from someone or something in order to join the set. And the other one is permissionless, obviously, when you as a node operator do not need any permission to join. You just go and join. All right, so now let's take a look at the situation that lied ahead when we started working on this product. So there was just professional node operators that were going through the permissioned onboarding rounds. Is that bad? Yes and no. So this model allowed the protocol node operator set to scale quite quickly and to fulfill this demand in terms of inflows of stake. But again, it was not quite enough in terms of the decentralization, and it required some kind of action from the protocol to change this situation. All right, at this point, all of you have the same context and the same knowledge that I had when I started working on this product. So we are kind of aligned right now. Now let's go into what we're gonna do about this. So we've identified the problem that the problem was that the Lido set was permissioned and was allowing to join only professional node operators, and it can't give you the enough level of diversity and decentralization, I guess. And the most obvious solution in this case seems to be just to, okay, what if we add a subset of node operators, and for this subset, we'll set up a permissionless entrance. And that would mean that anyone can join. There wouldn't be any problems with like operational stuff around like onboarding each and every single individual node operator. All right, seems like an solution. So, but for me personally, the most like the worst news was that having permissionless entrance to the module does not guarantee that individuals will actually join. That was quite a surprise for me, honestly. So, and now we as a big team who are about to solve this problem are going to figure out why it is so. So there are a lot of reasons why they will not join, starting from like social reasons that they just don't want, or they think they're not aligned with Lido, or they do not know about Lido. But we will consider just the very simple case. There might be a case that they just cannot join. Why? So what if we just create a permissionless module with permissionless entrance? What's going to happen? Will solo operators come to us? They can, but the probability of big node operators coming in and occupying the entire capacity of the module is way higher. So we need to kind of prevent these professional node operators from occupying the module. All right, let's try the following. We can list all the addresses of professional node operators we know and just say, no, you are not allowed. So this is for small players, this is for solo stakers, do not come here. So we just reject the entrance for them. Okay, that's possible, but what we can end up with is that these node operators, professional node operators, will just create new address that are not associated with their entities. And basically that's what we call sibling. And that's definitely not something that will help us to decentralize the validator set. All right, let's try to do the opposite. What if we list all the solo node operators addresses and allow only them to join? So we do opposite. All right, that's possible, but the problem here is that it is quite hard to identify if it is a node operator or not, because like on the blockchain and on the Ethereum network, you can like find any information about this address except for its owner, unless it was like voluntary provided by the owner of this address. So it is quite challenging to get this information. And moreover, and the biggest problem here is that if you list all of the addresses of existing solo stakers, it will mean that you are not allowing newcomers to join. So, and this issue doesn't solve in this approach. All right, so we tried 3 different approaches from the design space. Now, let's consider the following. What if we indeed create this list of solo stakers and allow them to join, but we will do it before we open module up for everyone? So before, we were trying to get 2 modules, the permissioned module and permissionless module, and we were trying to split this professional and solo node operators between these 2 modules. But what if we will not try to split them into 2 modules, but instead we will split them like in terms of time? So it means that we create a buffer for the module till the buffer it's a period of time during which the module will be permissioned, and we will indeed allow only identified solo stakers to join. Even though I told you that it is quite challenging to identify these addresses, it is possible to some extent using the machine learning models that analyzes the behavior of these addresses. So it is possible to some extent. You can use multiple sources for this, but the idea is that we do not split them into like different modules, because this permissionless module will be occupied by the professional node operators, but not from the day one. So there is a solution, and we've just came to the like one of the design solution from out of many. And basically, this is the same solution we made for a real product. And I haven't named it yet, but it's time to say hi to him. So the product me and my team were building is called the Community Staking Module, the first ever permissionless module for the Lido protocol that is currently live or mainnet in this early adoption phase. So this exact period while which we are allowing only identified solo stakers to join, and we expect this module to become fully permissionless at the beginning of the next year. So for those who've been involved in Ethereum validation or Gnosis validation, I definitely encourage you to check out this QR code and to check if you are eligible for this early adoption mode, for this early adoption period. And for those who are just interested how this story finished with all the design considerations around CSM, it was just 1 out of, I don't know how many, 1,000? Around, yes. So yes, check out the architecture of the module and hit me on Telegram if you have any questions. Thank you for your 15 minutes that you, the 15 minutes of your life that you give to me. I want to thank my team for working together, for building this protocol, and for you, all of you guys from this audience, for allowing me to let something that is very important to me into your hearts. And that's pretty much it. Thank you.